So as we make and analyze our scatter plots, okay, you can see the many I-CAM statements that go with this. Making sure you can identify your independent and dependent variables. Independent is always on our X or horizontal, or dependent on our Y. We're going to be looking at constructing them with an appropriate scale. So sometimes the scale is something that students often get mixed up with. Remember that scale has to be constant. We might identify outliers in a scatter plot. Some of these ones that you see down here really don't have outliers. And then we're going to be talking about correlation and causation. And causation is different than correlation. And so we're going to talk about those things today. We're going to talk about what two variables when we choose, if they're related or not. So as you look at this first part of vocabulary, scatter plot. So positive correlation looks like this. It's just going to be a scatter plot. When we make scatter plots, you're not connecting the points with lines. You should not have a line with those. But then tomorrow we're going to be talking about making trend lines. So scatter plots are simply plotting the points that they give you positive correlation as you think of it. The Y increases as the X increases. So as the X goes up, the Y goes up. If we're looking at this one, a negative correlation, as the X increases, the Y values decrease, right? So it's like a negative slope. And then the no correlation is when two things are not related. Whatever your two things that you're talking about, they have no relation on each other. They're not related to each other. There's no correlation, okay? And then that's different than causation when we talk about those. So they ask you on the bottom of this page to please label each relationship as positive, negative, or no correlation. So take a minute right now. Look at what your labels are. The elevation with temperature, the education and income, numbers of missed classes in your exam score, and shoe size and IQ. Abby, if we look at that first one, temperature with elevation, positive, negative, negative, definitely negative. As you go higher up in the mountains, it's getting colder, right? So we're talking about our elevation, right? As our elevation is increased, our temperature is decreasing, okay? If we look at that next one of shoe size and IQ, Sam. No correlation. Which we would think that. Although someone said that, Mr. Pauly said last year he always tried to show that the larger shoe size had the higher IQ, but I don't know if that's just right. So education and income. Owen, what was you saying?
Positive.
Positive. And down here, there doesn't seem to be that much of a correlation, right? It doesn't look to be that much, but if we look at the overall picture, and we really don't know if income here is monthly, if it's yearly, so this one would be positive. But if we were only looking at this part of the graph, right, this one would be no correlation, right? This one is no correlation between how much you're getting paid. You might be working at the family business, they might be paying you more, right? If we're looking at your education versus just going out and working. And if we are looking at that last one, exam scores with missed numbers of classes, Devin, what would you say? Negative. It's negative. Meaning that as you miss more class, you probably, more days that you miss possibly aren't going to do as well on your exam. So those are positive, negative correlations. So this next page, you're going to be asked to make a scatter plot. In your homework tonight, you're asked to make 3 scatter plots, okay? First thing we want to decide is it tells us make the scatter plot with the dollars spent X. So this is on our X-axis, so you can put that label down below. And our Y-axis is going to be the gallons bought. So down here, as we look at this, this is going to be the dollars spent. Okay, they tell us that. And my hint would be today when you go to do your homework for, I think it's questions 1, 7, and 8, they're going to give you a table like this. It's usually X and Y. Our Y then is going to be the gallons. We need to decide on a scale. So the dollars spent, to me, I'm looking at going from 4 up to 13. And I look at my numbers, it looks like I can easily go 0, 1, 2, 3, right, and go up to 13. Okay. For my gallons, I'm going from 1.1 up to 3.3. I might go by, because I have so many, I don't want to go up by just ones, because I have those decimals. So I might decide, you know what, my scale is going to be 0.5, then 1, then 1.5. Okay? So as I'm looking at this, I am going to plot points. I'm not connecting them with the line. So 10 gallons, or $10 spent, I go to 10. I am going to be at 2.5. So here's 2, here's 2.5. So 10, I put a point at 2.5. For 11 gallons, or $11 spent, I get 2.8. Right, so 2.8, kind of close. This is up to 3, right? Maybe a little higher than that, depending you're going to put it. Okay, so you're estimating that one. At 9, we're at 2.3. We had another one at 10 at 2.6, so it should be right above that one, right? So what you want to do is you want to plot all of these points. Okay, so you're going to plot all of those points as we are looking. So if you look at your graph with this one, it should look very similar to this. All right. So then it says describe it. As the number of dollars spent, and we would say if we are looking at this, if the number of dollars spent increases, right? The number of gallons bought is also what? Increasing. This means it should be a positive correlation. Okay. Let's take a look at that next part down. It says, look at the relationship below, predict positive, negative, or no, and if you were to graph them on a scatter plot. So first thing I want you to think about is what would like the graph look like of these. Okay, so if I'm looking at this first one, the number of hours he worked and the amount of money. So this would be our hours and this would be our dollars. What do you think that graph is going to look like? Positive, negative, or no correlation? What do you think? Probably positive, right? If you're an hourly employee, as your hours increase, it's actually going to be looking very linear, right? You might have some that are off a little, but pretty much you're getting paid the same amount per hour. So we would say that this is positive as we are looking at this. It has a positive correlation, okay? That's what my graph might look like. The temperature outside, so again, think of what your graph might look like. You have your temperature and people eating at the McDonald's. That's going to be on my other axis. Do you think there's any relation to when it warms up, more people go and eat out at McDonald's, and if it's cold, more people are going to eat? There's probably people that are eating at McDonald's. I mean, this probably looks something like this, right? I mean, just because the temperature, we don't know, that's not going to impact the number of people eating at McDonald's, right? So we would think that this one is going to have no correlation. All right. So then it says, well, the amount of money you owe your parents. I want you to look at these next two. I want you to think of making the graph. So the amount of money you owe and the number of weeks. So this would probably be our dollars that we owe over here. And then we would have, on this side, we would have the number of weeks. Same with this one, you're going to have population and the letters. And just take a minute and kind of think about what do you think your graph looks like. Check with your shoulder partner. about what you think your answer is going to be, positive, negative, or no correlation. And then if you notice right below that, it says, make up your own example. Classify the type of correlation, be prepared to share with the class. So the easiest one has been positive that people have been able to come up with. The hardest one that people have had to come up with is a negative correlation and the no correlation. If you can come up with one in each, that would be awesome. You're asked to do this also in your homework. So do these two, talk to your shoulder partner. Number of weeks go by. Ryan, what do you think? Amount of money you owe your parents. Number of weeks. Positive, negative, no.
Oh, it would be negative.
Probably negative. What did your graph look like?
Oh, it kind of looked like a down slope.
Would it be linear? Kind of? I mean, did it
Could
almost
be.
make a straight line?
Yeah.
It could be. It could be like 1 week you paid them more, right? Then the next week you didn't pay as much, right? It could be something like this. Or it could have been exactly linear. Each week you're giving them $5 to pay it off, right? Okay, I agree. Population of the city. So if we, where'd you put population, Ryan? Or Joe?
I put population on the y-axis.
Okay, population on the Y. Would it matter? No. So population here, and then this would be your number of letters. You could have it switched around. It doesn't matter, right? What did you have? Positive, negative, no.
No.
City of Fargo has more people than City of Grand Forks. Grand Forks has more letters, less population, right? So just having more letters does not necessarily, I mean, you could have towns all over, right? This is going to be something like this, right? Small towns, large towns, okay? So no correlation. Anyone ready to give me their positive, negative, or no correlation, their example? Joe.
I have a negative one.
Negative.
How long the wall is and how many bricks Trump has left.
No, we're not that one.
Okay.
Okay. How about another one? Anyone got any other ones? Abby.
I had one for no.
No.
The amount of stuffed animals a 7-year-old has, the amount of allowance they get for food.
Stuffed, the number, we'll put the number of stuffed animals and allowance. Possibly have no correlation. Although if you get more allowance, you might find more stuffed animals, but possibly no relationship. Anyone have a positive for me? Positive relationship, or
The number of hours you work, the more money you make.
number of hours worked. And your pay. Anyone else have a negative or a no? I had grades and height, right? No correlation. Grades and shoe size. I had a positive correlation in the last class. Someone said your height and your shoe size. And if you think of it as you start as a small child, like from 1, 2, up to at least, 12, 13, as you've grown, your foot size has possibly grown too, sometimes linear, sometimes not. Negative. Negative is the one that I think students and a lot of people have a harder time thinking about. One that I have used over in the past is that when you think of the number of people on a trip, or I'm going to say the number of people in a bus, okay? And I don't know if any of you have ever taken, like with your teams, like rented a coach bus, right? So you rent a coach bus and they say, listen, it's going to cost you $300. Now, if only one family goes, they're paying the whole cost, right? So the number of people on the bus and the cost per person, these two would be related, right? So that if I think of my graph of this one, here's the number of people, and here is the cost per person. And I'm not talking just the total cost, but the cost per person. And so that when there's not many people, the cost was really high. But as I add more people, my cost goes down. In that each family then only has to pay $20 to go on, or $20 a person. So like when you go on your ski trips with your church groups or different things like that, that set cost is, okay, we have to pay for the bus. And the more people that go, your cost goes down, okay? So something along that as you're thinking about those. So then the other part is identifying a relationship that is what's called causal. So causing. So causation is when a change in one quantity causes the change in the second one. So a correlation does not always have to imply causation. So you can have a positive or negative correlation, and there can be no causation, or there might be. So as you look at these two situations, and you write this down in your notes. So it says the number of loaves of bread baked and the amount of flour used. Now, we would think that's going to be what kind of a relationship, correlation? Should be positive correlation, right? Does that make sense to everyone? And have a positive correlation for that. The reason it's positive is because as I make more bread, it takes more flour. And in this case, it is also a cause, because baking more bread makes me use more flour, right? If I want those breads. So it is both, okay? Whereas the number of mailboxes and the number of firefighters, okay? So I want you to think about this one, the number of mailboxes. Now, if we're increasing mailboxes, what does that probably mean? We're increasing our what? If I had 500 new mailboxes, I probably added what? A lot more people, right? More families, more people. So when you look at this one, as we are looking at this, so when we talk about, this one does have a positive correlation, is what I'd want you to put down. Positive correlation, and the reason is that the number of firefighters tend to increase as our population increases. So our mailboxes are increasing because we got more people, and usually if we have more people, we need to add more firefighters. But here is the key thing. Installing more mailboxes does not cause the number of firefighters to increase. There is a correlation. It does not cause us to get more firefighters. Does that make sense? So the difference in a correlation is how two things are related, whereas the causation part is, does one cause the other to happen? In that first situation, when you keep baking more bread, it causes us to use more flour. Adding more mailboxes does not require the city to automatically add more firefighters, right? Give me a thumbs up when you got that part written down so I know I can go on. We just got a little bit left where you're trying to come up with or think about these next situations and if it causes it. So. Ready? Thumbs up. Am I ready to go on? We're done almost. Done, Joey? Almost. And as you looked at the project that you got back, it's more the explanation part that I'm looking at, like where you guys did the explanation on those story problems, and making sure you're really understanding it, not just like computing those statistics. So it says, is there a likely correlation between the cost of a family's vacation and the size of their house? So do you think? Because they have a big house, they have a big vacation. And we might say, yes, families spend more on vacation, they also spend more on their houses. Could you come up with a situation where that's not the case? Very much so. Yes, you could definitely say, you know what, they live in a small house because they want to spend all their money on vacation. So it could be the other way that it's related also, right? So you could say, is there a correlation? You might say that it's a negative correlation, so this one like this would be positive. And then it says, if there is a correlation,